Okay, let's go ahead and get started. So today's main topic, is going to be about lists. A couple things that I want to go over that I thought deserved a little airtime. Let me get my file watcher going here. Quick sanity check. Oh, see, that's why we do a sanity check. Because I did not have that file hooked up correctly. Okay. See, every time I do that sanity check, and it doesn't matter, this is for the time that it does matter. Okay. Good. Cool. Let's see. Let me just open this for reference if I need it. Oh, that's good there. Okay. So I just want to give folks a reminder. The deadline is coming up on the 9th to the deadline to interview is coming up on the 9th. If you're in this class, you have that extended. Apologies, I should have just said. I guess that's the 16th. So you'll have until the 16th to complete your interview for the August data science immersives. So if you haven't gone through the application process, go ahead and do that. If you don't know how to do that or you don't know where to find that, just at me in the channel, DM me, and we'll get you squared away. But go ahead and get that process started. At least get to the point where you're looking at the coding challenges that you need to complete. There are 2 coding challenges. They're kind of like Code Wars problems that you'll need to complete before you'll be able to sign up for a technical interview. So you need to complete those a little bit before, and then sign up for your TI and complete your TI by the 16th. So yeah, just a reminder to apply because the deadline approaches. Got less than a month. Cool. Changing gears, I wanted to go over a little bit of importing. Importing is something, so we call it when we like bring in another file into the scope of our program. So I'm actually doing this kind of weird thing where this document is my program. This is actually the document that I'm running all the time in every class. And I just do this thing where I just import the file that I want to execute, and it executes that file when it imports it. So I can import my own files like this. I don't so much want to show you how to like import your own files at this point. You'll learn that there's not terribly much to it. You can just look for a tutorial, and it's like really like a 5, 10, 15, 20 minute thing, 10, 20 minute thing, and you'll probably have a pretty clear handle on it. But I did want to mention it because it's how we bring in other libraries into scope. So just as this is the last module in the intermediate Python, and I just popped that in Slack there. You can go ahead and take a look at that. It'll give you an idea of how to bring in a module. I'm going to go over it really quickly, and that's going to tie into help and dir, which I'm going to cover for lists anyways. I know I talked about these briefly, but so let's say I want a factorial function. Well, I could def factorial, and I could write a factorial function, and factorial function isn't terribly complicated. So I might just write a factorial function. But there's one that exists in Python. It's just not in scope. It's not available by default. You have to tell Python to bring in the math library and import it from there. So the way we can do that, the way I recommend that you import libraries, there are sort of two forms of this. There's the easy, clunky, safe, robust way, and then there's the sleek, fancy way, which is a little cleaner but a little more complicated. And I'm going to recommend the easy way, especially in the TI. I really can't stress this enough. I get a lot of people in the TI who want to kind of impress me and like write code that's going to wow me a little bit, and I can be wowed. That's fine, but you know, code that solves the problem and doesn't wow me gets you past the interview. And I always appreciate like when people are like, I'm not going to try to, I know how to solve this. I know how to use the tools at my disposal that I'm comfortable with to solve this. And that's something I really like to see, so you don't have to write the fanciest code. You just have to write code that works. Where the TI is concerned, that is an excellent guiding principle. Just do things in a way that you can rely on. If you feel like, oh, this isn't like, quote, the best way to do this, that's okay. If you know you can make it work, just make it work. So the easy way is to just import. Now I wanted to import the factorial function. I'm going to import the whole entire math library. Now I can access anything in the math library. So I can actually use and I suggest that you do this. I mean, in any class, I'm assuming, I presume, and maybe I shouldn't, maybe I should say it every time, start your REPLs, get your environment loaded. If you don't have an environment loaded, go ahead and start up a REPL session now so you can code along with what I'm doing. Even if you don't end up coding along all the time or with what I'm doing, even if you end up watching, like having the REPL open, if you see something that I do and you want to try it out real quick, you can try it out. And a lot of questions that I'm going to ask and a lot of basically all the breakouts that we're going to do are going to require that you have your REPL open. So open up your REPLs and try this out. Go ahead and type import math, and then let's say I'm just importing math for the first time, which perhaps many of you are at this point. Oops. I just want to see, I always like to start with a new library. There's a ton of libraries in Python. Some of them I don't think I've ever used. But I always like to see just what's in it. So the first thing I always like to do is just kind of take a glance at what's in that library. So I'm going to say print dir, dir, math. Okay. This is going to show me everything that's in math. So just to be clear here, if I don't do that, if I run my code, nothing happens. The math library is in scope, but obviously I'm not doing anything else. I'm not printing anything, so nothing happens. If I try to print the directory of math without importing it, I get a name error. It says name math is not defined. So I need to import it first. I need to make sure it's in scope first, and then it'll give me, it's kind of funny, but dir literally returns a list of strings with all the methods. and properties of the thing that you pass to dir. So dir is short for directory. So this is the directory of math. You know, you can just think about it. Just these are just the things that are in there. So I always like to look through here and just kind of get a sense of what things are. I might see something that I think, oh, maybe like E. I know what E is. I bet I know what E is. Let's see, I bet there's a pi in here. I mean, there is. I know there's a pi in here, so I could look in here and I'm like, oh, I wonder if there's a pi. Oh, look, there's pi. Okay, cool. Pow, maybe that stands for power. It does. Perhaps there's some other ones that you've seen. Perhaps you've seen trunk, which is short for truncate. Sign, NaN is not a number. X, which is a lot like E. Seal, which is ceiling, right? So I know a lot of these, but I think whether or not you think you're gonna know some of these just by looking at them, just look at them anyways, because you might be able to make some interesting inferences, you know. And then if somebody says, "Oh, use this function from the random library, it's called square root," and you're like, "Actually, I printed out the directory for math and I was searching around and I noticed that square root was the part of the math library," which I don't know why somebody would confuse square root as being in random, but there you go. So you can just look around and see what's available that way. Sometimes it's not super helpful, but at least gives you a sense of what's there. Often it's more helpful than you think. Okay, so that's one thing. So let's say I find something that piques my interest, like, oh, there's factorial. That was the whole point of doing this. So I see something that piques my interest. Now I can use help. And I can say, I can access anything in here by saying, I have to say the name of the library, math, dot, and then the name of the thing I'm interested in getting help on, which is factorial. Now, factorial is a function. So just like any function, it takes parentheses, it takes an argument. It works like the factorial function that many or presumably most of you have built at this point. The factorial function that you've seen Tovio and I build a few dozen times maybe at this point. But when we're passing it to help, help takes an uninvoked function. So this is an uninvoked function because I'm leaving the parentheses off. So putting the parentheses off will make Python attempt to invoke it. Leaving the parentheses off is valid. It's valid Python. It just won't invoke the function. You're just specifying the function. That's all you're doing. You're just saying this function, the factorial one. Okay, so I'm going to run that. And this is, so you don't need to print help. If you want to, you can. It's not going to hurt anything, but you don't need to. You're going to get a none at the bottom, but whatever. So we'll just call help. Help on built-in. See, I've got dir still printing out. I don't really need that. Help on built-in function factorial and module math. Factorial takes in x. You can ignore the slash. Find x bang is shorthand for factorial. That's generally when you're writing, you know, formal mathematical notation. X exclamation mark or n exclamation mark means factorial of n or factorial of x. So raise a value error, raise a value error if x is negative or non-integral. Okay. So this tells you that it's gonna find the factorial of x. I don't know why it doesn't say finds and returns the factorial of x, but you know, presumably it does return it. And then this is just going to tell you about an error that it will raise if the number is negative or a non-integral. So that's it. So you could go through and do this with anything. Let's look at degrees. Degrees takes in x, converts angle x from radians to degrees. Okay, atan. Return the arc tangent measured in radians of x. So You can go through here if you want to print all of these. You totally could. So yeah, that's an example. Another example is let's just take a look at the import random. Let's print. Actually, okay. I'm gonna let you do this one. So why don't we'll make this a little breakout. I want you to explore the random library. Paste in your code, formatted, and pick something from the random library. Pick a value. I forgot to mention, just if anything starts with like dunders or underscores or something, if it doesn't have like a regular all lowercase letter name, just ignore it. I hate saying stuff like that, like, just ignore it. You don't need to know these for now, certainly not for the technical interview. There will be a day where these will make sense, but just pick a regular named method, get help on it, and then paste in the help. So I'm gonna put a whole 5 minutes on the clock for this one, because I really want y'all to know how to do this. So the timer's started. I am gonna keep talking, which I hope is not terribly annoying. So the goal here is you're going to import random and do a similar kind of exploration on the random module. And you'll call help on some method in the random module. So the reason I want to give a whole 5 minutes for this and give people an opportunity to kind of try this out is I'm not sure if anybody has heard, like, you'll hear more seasoned programmers say things like, you know, what you want to, I mean, you'll hear me, you've probably heard me say this, you might have heard Tovio say this, but perhaps you've heard other more experienced programmers say this, that you want to learn to get the language to kind of program itself. And this is kind of one of those moments, right? This is how I get Python to teach me things about Python that I don't know. There's a little bit of a skill in learning to read the docs and then play around with it. Play around with the thing that you do. Or like, sorry, it was kind of an incomplete thought. There's a little bit of a skill to learning how to read the docs, and then, you know, as soon as you read the docs, you want to like test out the thing that you read about, see what it does. That's something that you could add to this too. Sorry to move the goalposts, but we'll call this extra credit since I didn't leave it in there, right? So let's say I want to do help on like math dot let's pick something INF. Oh, okay. That's a big one. Let's do a smaller one. Cosine. So I'll take in cosine, return the cosine of x measured in radians. So now I want to use cosine just to confirm that I know what it does. So let's say cosine of 45 measured in radians. Ugh, I don't think in radians that well. So is it going to be 0.5? Yeah, okay. So just call it and just make sure you can call your function. Cool. Let's see what we've got. Okay. $25. Ooh. Okay. I want to wait for a few more answers to come in. I'm going to put some more time on the clock. So I want you all to be trying this. So all you're going to do is you're going to do dir, you're going to import random, you're going to print the directory of random, and you'll get a similar thing like this and just pick something from random and then call help random dot that thing that you picked and then try to use it. You don't have to fully comprehend what it does, but just try to use it in a way where it doesn't throw an error. Okay, we got a few more coming in. Good. All right, let's see 4 more answers for this. 4 more. Also, I noticed a number of people have joined the Zoom call since attendance. Go ahead and just post an emoji in. And if you are joining us, more recently we were just doing an exercise where, let me share my screen again. I give an example of how to explore a module that you import, and this will work for actually any built-in data type as well. Lists, dictionaries, strings, anything, as well as modules that you have to import. So. Two, three, 4, 5, 6. Okay, 2 more. 2 more, and then we'll move on. Okay, cool. We'll go with that. Great. I see. So it looks like we got 10 responses for this breakout. We've got more than 10 people on the call. So if you're in the middle of this, feel free. Yeah, cool. We're getting some more coming in. If you're in the middle of this, feel free to keep kind of working on it and playing around with it. If you're having trouble or if you're getting an error, feel free to comment out your code or whatever and ask me after class. We can troubleshoot this. This is a really useful set of tools. Hopefully that's clear, right? Dir shows you everything that's in there, kind of at a glance. Help gives you information on something specific. If you want to be super verbose, you'll get a ton of output, but you can do help on the whole library. Like I said, you'll get a lot of, oops, well, I guess that's not too terribly much, but we get a lot more this way. I guess that's not so bad. It's a little more in depth than Dir. That's another way to do it. So if you're familiar with using your terminal as well, I'll be really quick about this. You can start up an IPython session, or if you're on Replit, you can just type in Replit and this will work. And then you can import whatever library you want, and then help, random, get your help docs, and then to exit out of this, you hit Q, and then you can find whichever method you want. You can say help, random.choice, like that, and it'll tell you how choice works, and then you can try it out in here. You can do random.choice, and then 3, 5, something like that. So I personally like to go into the terminal when I want to do this kind of exploration like this, and kind of read the docs and check things out. And I do this fairly frequently, not infrequently. I definitely don't have every method and every Python module memorized, so nor do I expect you to do that. Okay, cool. Running tight on time, so I know how much you all love the overview, but unfortunately we're gonna have to skip it. No, I'm just kidding. Sorry. Abstraction, data types, abstraction, control flow, and iteration. Right? Our types, int, int, float, bool, none, str, string, and list. Am I missing one? Probably. Variables and functions. I'm sitting my housemate's dog, and she gets insecure and she's licking my hand as I'm trying to type, so apologies, I'm typing a little slow. If, elif, else, conditions, conclusions. Iteration, we've got for loops, and I kind of gave a glance at while loops, which we might get into today with any luck. Cool. So there's a real quick overview. Again, I know I say this all the time, but the reason I go over this every time is so that you have a sense of whatever we're learning today, and we're going to be focusing on lists. That lists are a data type, and that's where they fit in. And the reason I do this is a long time ago when I was first doing this, we went over a thing on lists, and somebody was saying, I don't know when to use a list or a function, and I was like, oh, it's kind of not like not knowing when to use an apple or a chainsaw. They have very different applications, and I was like, well, okay, maybe that's on me. Maybe I can make that a little clearer. So lists are a data type, And yeah, just so you get a sense of how everything kind of fits together and what role everything plays in relation to everything else. So cool. Help and dear, I just went over these. Of course, we just went over these with the thing we just went over with importing modules. But we can just quickly, I'll demonstrate that we can do this with any type. Dir, let's get the dir of a list. So this is the directory of a list. You can see there's a lot more of those dunder methods, the magic methods, that we're not going to get into. I'm sorry to do that. And then there's just these methods here. I know I kind of showed that the other day. That's most of what we're covering here, most of what we'll be covering. We could do, let's do the dir of a string. See the pattern here? Casehold, center, count, encode, ends with. And if there's anything in here that you're curious about, call help on it. Do, you know, maybe I'm curious about, I was like, ormat, mat? But that says format map. Okay. Let's see, expand tabs, find, encode. Ooh, that sounds interesting. I like things that have to do with codes. So maybe I'm curious about encode. I could do, I could do help on stir dot encode, or I could do it like this, or I could do it like this. Just any old string, and I'll call encode, get help. This is going to tell me all about encode, which we're not going to do right now, but if you want to know about encode, that's how you get Python to tell you. Cool. So we went over some of these. I kind of ordered these in, I put these in something approximating the order of what I would assess as most important first. Vaguely, although I've got count way down here, and count is really useful, so it's approximate. So len is something that you use all the time. You've seen me use it before. I've talked about using len in conjunction with range. Let's do a little quiz on this. What are the inputs to range, and what are their types? I'll put a minute on the clock for this. And I do want to see a few answers before we move forward. So the inputs for range and their types. Most important is the type. Cool. Great. So we have sorry, what am I? I kind of lost that thread of thought there. When we have a range, if I have a situation where I want to iterate through a range that is equal in size to the number of elements in a list, right? That's like being able to iterate through the indices of that list, right? So if I have if I have a list with 10 elements in it, and I have for I in range 10, that gives me elements, or that gives me values of I between 0 and 9, which are all the indices of the list with 10 elements in it. So if I wanted to iterate, quote unquote, iterate through the indices of my list, I would say for I in range len list. So len is a very useful function. It comes up all the time that you want to know how big a string or a list is. So you can use len, and that'll tell you how many characters are in a string, how many elements are in a list, or a tuple, or a set. So I popped in the last half of Tovio's lecture last night. Some of you might have seen me. When Tovio was talking about the cardinality of a set, that has to do with the number of elements in the set. And in Python, if I wanted to get the number of elements in a Python set, there is a set data type in Python, I can use len. So len is de facto cardinality of a set, if you want to think about it that way. Cool. Okay. Sum takes in a list of numbers. So you can see I've got a list of numbers up here. Oops. I should just put this, I won't reuse the same list every time. So I've got this list of numbers. I can pass it to sum. Let's do this. I've got this list of numbers. I can pass it to sum, and it will tell me the sum. So 4 plus 3 is 7, plus 6 is 13, 14, 15 plus 7 is 22. If I try to get the sum of a list of strings or a list of, let's do this, let's say a list of numbers, but one of them is a string, in either case, it's going to give me the same error. Doesn't know how to add a number to a string. It doesn't know add it, do I mean to add it in the number way or in the string way? Can't figure that one out. So, okay. Min and max. We talked about these. Oh, Python. You want all the lists to be defined, don't you? Okay. So the max of this list of numbers is 7, the min is 2. Max is the largest number, min is the smallest number. You can actually do min and max on a list of strings. You can see dog. I mean, clearly dog is the maximum element and apple is the minimum. Oh, that's kind of funny. Because that makes it look like it's gonna, because dog is all the way to the right. Oh, I know why I did that though. So just to be clear, it's not about where it falls in the list, right? Dog is still the max. And the reason for that is, if you think about it, like numbers have an order, the alphabet has a canonical order that's not necessarily inherent to the alphabet like it is to quantifying digits, to numbers in the way that we think of them. But there's just an accepted canonical order for an alphabet, for the Latinic alphabet that we as English speakers use. So just like 7 comes after 6, D comes after C. It's the same logic. So a letter or a word that whose letters occur later in the alphabet correspond with a greater word, a larger word. That's one way to think about it. The other way to think about it is that it converts each letter to an ASCII value, which is a number, and then it compares those numbers. That is actually mechanically what is literally happening. If that doesn't make sense, then there's the alphabet analogy. Okay, any and all. These are Boolean operations. I think these are cool functions. I think they're like I look at them and I'm always like, neat. That's really neat. Like I said before, I'm not sure I've ever actually used these in other than to demonstrate that they exist in classes that I've taught. In my own coding, I'm not sure that I don't recall actually ever using these. So, not saying that. I mean, it's possible that there's some obvious way where these are really helpful, and I'm just totally missing out. I don't know, but yeah, they're there. I give them a little bit more of an explanation than that, sorry. So all, remember this idea of truthiness and falsiness? So these return Boolean values, right? So all returns true if all of the values in the list passed to all are true or truthy. So 0 is falsy, so all is going to return false. Somebody's asking, why is enumerate not in help? That's a good question. Enumerate is a function. So if you notice, len, sum, max, min, any, all are also not in help, which is kind of unfortunate. I'm not sure how to get help to show you a list of all the built-in functions. But I know you can find a list of built-in functions online in the Python documentation, and then you can call help on those functions. Like, for example, I could say help on enumerate if I wanted, and this will tell me about enumerate. So if there's a built-in function that you encounter somewhere out in the world, like on Stack Exchange or something, and you want to know more about it, you can just throw it into help, and you can read about it in your terminal, which is the way I like to do things. So it's an interesting thing. It's only the methods that are shown, because the methods are literally properties. They're literally part of the list object. So somewhere in the catacombs of the Python code, there is defined a class, what's called a class, or an object. If you're familiar with object-oriented programming, Python calls them classes, or objects, but the official name is class, and to make one you use the class keyword. But somewhere in Python there's something that says class list, and in that definition of what a list is, there's a sort method and a reverse method and an append, extend, remove, pop, count, index, but there's not an enumerate. Enumerate, zip, len, any, all, min, max, sum, those are all defined separately. Those are all defined as just functions on their own. So cool. Yeah, great question. All right. Sort. We've talked about sorting a little bit. There is the sort method. It is tempting because to use the sort method because there's this possibility that you don't do potentially unnecessary data duplication. There are schools of thought around in computer science and in programming that are very centered around high efficiency. I think those ways of thinking are a lot of fun, and I think they have their place. And I think, all of you are here because you want to get in through the TI and into the DSI, and I don't require that you code in a way that is maximally efficient. A lot of times highly efficient code becomes hard to maintain in other ways, or difficult or dense in other ways. And a lot of times writing slightly less efficient code might mean that it's not only easier to maintain, but a lot of times it's less error prone. So there's a trade-off. There's the shiny, high speed, highly optimized code, and then there's the duller, kind of less interesting, robust code. But I think writing robust code is not to be underestimated. And part of writing robust code is making it maintainable. Part of something being maintainable is that it's easy to read through, that it's reading through the code is a clear explanation of what the code does. If you know the sort method, it's not terribly complicated to see what it's doing, but if you're a beginner and you want to sort things, what I really recommend doing is just using the sorted function. And it's a function, so it's not a method. So just really quickly, let's kind of give this example again. Let's dog. That's you. I was talking to the dog. All right. Oops. Okay, so I have a list. It's got elements in it that are out of order. I'll print the ID of the list and the list, and you can see the ID and the list. Then I'll sort it, and just to prove that sort does not return a copy, or for that matter, return anything at all, I guess it returns none, right? I'm printing it out, and you can see none, right? So the dot sort method returns none. What it does is it sorts the list in place, which is efficient, but it also has the side effect of well, I hope you didn't need the original unsorted list, because now that list is sorted forever. So then you can see after the sort call, I print the ID in the list again, and the ID stayed the same. So it's the same object. That tells me that sorting happened inside of this list. It happened internally, or in place. It happened in place. We call that an in-place operation, an in-place sort. So this performs an in-place sort, and then we see the value, and you can see the value is sorted. 2, 3, 4, 6, 7. The sorted function why don't I do this? The sorted function you can see the sorted function just returns the sorted list. And I'm going to do this in a variable. sorted list equals sorted list. And let's get the, no, I don't want to do that. Go away. Get the ID and the sorted list. So you can see, oh, it's a little weird because it ends in the same digits. Okay, that's better. You can see the IDs on the top and bottom are the same, but the values are also the same, right? So no change was made to this list. And then the middle list has a different ID, and it's the sorted version of it, right? Like if I really wanted to, I could emulate the sort of emulate the behavior of the sort function, sort method, excuse me, and I could just overwrite list, right? So now I have something that acts a lot like mutability if I want it to, or acts a lot like immutability if I want that, right? So you learn one tool and you get most of the, you get unique behavior plus effectively, or in a lot of cases, it's not exactly the same because it's still not an in-place operation. There's some duplication that's going to happen no matter what when you're using sorted. There's some memory duplication. You're getting a copy of that list back. So there's some duplication that's going to happen even if it's for a short period of time. But if you wanted that mutable behavior, you could do this, and then the duplicate list will eventually get cleaned out of memory. So that's kind of why I encourage you to use this, to learn how to use the sorted function, because if you really need a mutable style behavior, you can kind of emulate it, and it's probably going to work fine. So, okay, let's just look at reverse real quick. Reversed. So the same is true for the reversed method, like the like the sort method. It is mutable. Let's just do the same thing. reverse. Reverse. So, not so bad with the reverse method. So you can see I'm printing out the ID and the value. The IDs are the same. I'm doing it before and after the reverse. Again, the dot reverse method, like the dot sort method, doesn't return anything, so we get a return none. When we print it out, we get a none, right? And then the thing is, the change that reverse causes isn't so permanent, because if you call reverse again, then you have the original order. So reverse is a simple but potentially slightly weighty algorithm. Let's do this. So let's look at the reversed function. So this has a little bit of a unique behavior compared to the sorted function. It does something a little different. So we'll call this reverse list. We got a question: if a machine crashes in the middle of a sort, does it make a sound? No. Does the list get lost or scrambled? Actually, I think that is the same Zen parable as if a tree falls in the forest and no one's around to hear it. Does it get lost or scrambled? So if the, okay, so the program, usually we think about the program running in RAM. So if the machine crashes in a way that it powers off, and the RAM loses power, and everything that was in RAM that was not saved to disk, we don't have disks anymore, right? But that wasn't saved to your ROM is gone. So I guess it would get lost, but it wouldn't get lost for any reason other to do with the sort. It would get lost because the power to the RAM goes away, and then that just means any data that was in there that wasn't written to your hard drive isn't there. So okay, so reversed. So I want you to you can see reversed gives us something pretty different. So the reversed function, you can see it returns, when I print it off, it doesn't return a list at all. It does return a different object. Notice it's a different ID, but it is not a list object. This is a, and let me prove this. Oh, type. Let's take the type of it, and we'll see the value. So you can see that the type is class list reverse iterator. So this is literally its own type. It returns an object that is called a list reverse iterator. That's the name of the object. And that object is essentially like directions, or you think about it like a function, like it's instructions on how to iterate through that list backwards. So with the reverse method, it takes all of, I wish I had a deck of cards here or something. I'm looking for something to shuffle, right? But it takes, well, pretend I'm shuffling my fingers, right? So it takes all the elements in the list and it reshuffles them so that they're backwards. That's the reversed, the dot reverse function. The reverse, oh my gosh. I keep mixing up my words. Okay. So the dot reverse method takes your elements in your list and it reshuffles them so that they're backwards. The reversed function just describes how to, instead of go from left to right, go from right to left through a list. It's an object that just essentially is that description, right, for a given list. So there's no computational overhead to reshuffle the elements in the list, and there's no memory overhead to duplicate the list and get a reversed copy. There's just the instructions on how to go from right to left instead of left to right. And the reason this is useful, you might be looking at that going, okay, great. Why would I ever need instructions on how to go from left to right to left rather than from left to right? And the reason that you might want that is in a for loop, for I in reversed list. If you want to iterate through a list backwards, the reversed function is definitely the preferred way to do it. Most of the time you want to most of the time that you're reversing a list, you're doing it specifically to iterate through it backwards. So most of the time, this is the application for it anyways. And again, the function is preferable because it's easier to use. It doesn't come with a mutation, so your data stays predictable. And it actually is more performant in this case. So why well, I don't know. I could see potentially some reasons that this could exist, but for y'all right now, I would not worry about the dot reverse method. The reason that I want to show it to you is if you see it, like, I expect that you're doing other kinds of research outside of this. That if not now, then someday you're going to be on Stack Exchange, and Reddit can be a good place to learn about coding and coding questions. Although it's Reddit, kind of a mixed bag, but the internet in general is a wealth of information about programming, and you will see this out there, and I want you to know what it is. As far as the tool that I want you to use, that I would encourage you to use, I would say reversed function is the better one to use. Let's just print I. So 7, 2, 6, 3, 4. So that's 7, 2, 6, 3, 4. So quick note on this. If I really did want to turn this into a list, I could, like this. I could just cast it as a list. Super simple. Now I have a backwards list. Nice and easy. And of course, I could sort of emulate that mutability behavior by just overriding the same variable, and then it's like fake mutability. Okay. As an interesting side note, if I have a list, which now I do, I can reverse it with a slice. Nope. -1. So this will reverse a list as well. Now this returns a copy. So if you want to reversed copy, a reverse slice will do that for you. I'm not sure about the real world application of that, but if for some reason you wanted to copy a list, you wanted a copy of a list that was a different object, you were willing to go through, have some duplication happen, and you wanted it to also be reversed, you can do a reverse slice. Maybe there's an application for that. Cool. All right, let's take a short break. Let's reconvene at 10 after the hour. Somebody's asking, is it better to use the reversed function than a reverse slice? I would say so, in my opinion, yes. And we can open up for questions after the break. But yeah, go ahead, stretch your legs. I'll be back in a minute, and we'll get going soon. Okay, that's the break. Welcome back, everybody. I'll give you a minute to settle in. Get your cameras back on, if and you please. I'd be much obliged. Get started in a second here. Cool. Somebody's asking, when using the help function, there are definitions that come back with a slash. Oh, okay. Let's show one. Did enumerate do that? No, it didn't. Let's do import math. So the example they're giving is with costs from math. So we'll say help on math dot costs, and so cost has this slash in it. I had always thought that this was a reference to self. Something I was doing the other day made me doubt my assumption about that. So I actually need to verify that what that means, but I've always understood it as it's telling me that it's a property of something else. I always notice it in methods, but I need to actually verify that. I'm like 90% sure that that's what that is. If you'd asked me like 2 days ago, I'd have been like, I'm 100% sure, but I forget what it was. I don't remember what shook my faith in that assertion, but yeah, I'm almost certain that that's the case, but I'll go look that up after class and post something about it. But if it helps, I've understood it that way for, I don't know, years, and it hasn't let me down, so hasn't led me astray yet. So okay, cool. Let's get back into things. Append. I kind of feel like y'all know append. We're just going to show it anyways. Let's say I've got a list, and let's just demonstrate this with a, okay, we'll just do it with this, whatever. So append just adds something to a list. I say list.append, print. Let's do this ID list thing. I just need these. And then let's print. So we have to pass it something. So let's just say 57. I don't know. Okay, so you can see same IDs, so it's the same list. Here's the list with these elements in it. Here's the same portion of that list with the element appended onto it. So append just adds something to the list. Extend is kind of like append. One thing that I'll see people doing with append when they have to like add multiple things, they'll do like, oh, well, I'll add this and this and this. And the problem is append takes exactly one element, but 3 were given. So you can't append multiple things, but you can extend. Now, small pitfall, extend takes exactly one element as well, but the element that it takes, or exactly one argument, the argument that it takes is a list. So this is a de facto append multiple things. That's all it is. So it takes a list as an argument and it extends the list that's calling extend, the list on the left, by the list passed. So it mutates the list on the left. It does not mutate the list being passed. And you might think, well, why couldn't I do that with append? Anybody know why append is different? So if I append, how do I do this? Let's do this. Versus if I append, then this part appends a list. So append, if I pass a list to append, it appends the entire list. It appends one object, which is the entire list. If I pass a list to extend, which I have to, it puts all the elements in the list passed in the list that I called extend on. Yep, it gives a sublist. Exactly. Yep. So that's extend. Okay. Remove and pop. So these take things out of the list. And why is insert not in here? Is insert not in here? Insert's not in here. We got to do insert. Insert goes with append and extend. Oh, I'm glad I caught that. I don't know why insert's not in there. I'll have to insert it in there. Little list joke there for you. Oh my gosh. Okay. Insert. So insert, I think about as akin to append. List dot insert. Oh, and I need to just do this every time. Just copy this whole thing every time. So let's do insert. And I'm printing off these method calls. You don't, hopefully it's clear you don't need to do that, but I'm doing that just to make it really, really clear that they all return none, all of the mutable ones. Not every method by definition returns none, but all of these ones that cause a change in the list, that cause a mutation in the list, they don't return anything. So I'm printing them off just to reinforce that. Because when you're calling a method in a place where you're trying to use the value, use it as the value that you expect it to be, it isn't. It's none, right? It just causes that value to exist by changing the list you call it on. So it's an important thing to really grok. So insert takes an index and it inserts an element, let's just do hello, before that index. So 0, 1, 2, 3. So it's going to go up to 3. So it's going to put this hello before the third element. It's going to put it between the 6 and the 2. And that'll become actually the new index 3. So I can use insert to put an element anywhere in the list that I want, except at the very, very end. But I can do that with append. That's all append can do. All you can do with append is put something on the end. You can put something anywhere else with insert except at the end. So that's how insert works. Pop and remove. Okay. So let's do something here. Let's say 4, 3, 6, 2, 7. Let's put another 6 in there. Let's make these very conspicuous. Let's put some 99s. Okay. So let's say I have an element that I want to remove, and I know the element, not the index of the element, but I have the information of the element that I want to remove. Element to remove. So in this scenario, I know the element that I want to remove is 99. So I'll say list.remove 99. So notice which 99 did it remove? The first one or the last one? Or both of them? Obviously, there's still one in there. First one. I don't even know why I'm asking this question. It's kind of obvious, right? It's that one. That one's gone. So remove removes the first occurrence of the element that you ask it to remove. I always get this mixed up with the replace function method in strings. So let me actually do this. I am going to read the docs just to show you how helpful the docs are. See, why would I remember how remove works? I don't use it that often. I try to kind of avoid using it if I can get away with it, and I'm pretty good at it. So remove takes in a value, and it's a method of built-ins list, removes first occurrence of the value, raises a value error if the value is not present. Okay, so it does confirmed, it only takes in one argument. So I'm getting it. There's another method for strings, which is weird because the strings are immutable, but it's called replace, and I just get the two confused. I've gotten the two confused since I learned them. So yeah, to this day. Anyways, so removes the first occurrence. So if I want to remove all occurrences, I have to use the count method, and I have to throw it in a for loop. So we're going to do the count method with this. So if I do, so first let's just look at the count method. Yeah, let's look at count. So let's say print, see, I got to do the thing every time. So count gives you the number of a certain element in a list, right? So you have to say list dot count 99. 2. So notice count does return something, and it does not cause a mutation to the list. So count and index are the only two immutable methods for lists. They're the only two methods for lists that don't cause a change to the list. Just these two. It's important to remember that. These return values. Count and index both return values. So if I want to know how many 99s are in the list, and I'm not even going to do those because we don't need them. If I want to know how many, let's see, how many 7s are in the list? How many 1000s are in the list? How many hellos are in the list? Right? So there are two 99s, there's 1 7, there's 0 1000 and 0 hellos, right? So if you try to count something that's not in there, that's totally valid, you just get 0 because it's not in there. So let's say, why don't we make this a little breakout? I want to use the remove method I'll kind of write a scaffold here. Okay, so I want to remove 99. So I've got to write a, I'll give you a hint. I've got to write a for loop for blank in what? In blank. And I'll give you a hint. You got to use count. You'll do the count of 99 somewhere in there. So your job is to figure out what to fill in here. And actually, you don't even need to fill in this part. You just need to fill in this part. So just put in that part. Let's put 2 minutes on the clock for this one. All right, we've got a couple coming in. I'm going to give it another minute for this. Okay, about 20 seconds. Okay, go ahead and get in your answers. So for this, we can use range. So if there's this class of for loops that you'll write where you just want to do something a certain amount of times. Well, we want to do this how equal to the amount of times equal to list.count of the element that we're trying to remove. So if I said lm to remove, I'll just say rmv list This could be 99. I'm just going to call it remove. Right, so I can put whatever element I want in here and it'll remove it. So that'll remove all of them. So count and remove kind of go together well. If you want to remove all of something. Okay. Okay. Let's look at pop. So pop takes an optional argument. It's kind of like a reverse append. If I just call pop without an argument, it's going to just remove the last element that is in the list and return it. So notice it does return. It does return the values. So if we look at this, list equals this list. Sorry, I had a minor distraction there. And the last element in it is 7, right? So pop is just going to pop off that last element and give it back. So this can be a really useful thing. I try to, in general, if I'm thinking about a solution and I think anything to do with like removing or shrinking the size of something, I always give it a second thought and think, is there a way that I can do this with uh, additive with an additive only approach? And the reason for that is I don't want to get too in the nitty gritty of this, but additive accumulation tends to be more robust. It tends to be easier to manage. It also tends actually to be more performant. You'd think like in a lot of cases like reducing the size of something would be more performance than like more performant than like a standard accumulator maybe where you grow something to the right size, right? But a lot of times a standard accumulator actually is, most of the time it actually is more performant if it's possible to do it that way, unless there's some constraint on the problem where you like have to do an in-place operation, or in certain scenarios I've encountered where a reductive approach, i.e. where I start with something that has a lot of elements in it and I reduce its size, where occasionally I've found reductive approaches are more performant. So occasionally there's good reason to use it. Occasionally I will use pop, but in general I tend to approach things from like trying to do additive solutions first, because like I said, I just think they're more consistent, they have less problems, they're easier to manage, and usually they end up being better, equal or better performance anyways. So but for problems that require something like this, pop is really useful. It's a function that's really worth remembering, and it's really nice that it returns the value. Now, pop is kind of the weirdest one out of the ones we're talking about, because everything either causes a mutation or returns a value in some way, and pop does both. It's the only method that I know of that does that both causes a mutation and returns something. So it returns the thing that it removes, and that can be really handy. So it's definitely a function that's worth remembering. I can't say I use it, like I said, as a matter of principle, I kind of avoid using reductive approaches, but when I need it, it's just really handy. So it's really worth remembering pop. You can also pop something from any index. You just tell it whichever index you want. So if I want to pop the first thing, oops, I don't know why that happened. If I want to pop the first thing, that's going to pop off that 4. If I want to pop off the 3, pop off the 3. Oh, excuse me. That's index 1. I was like, wait, what? That's index 1. So I can just tell it which index I want to pop, and it'll pop that. So with remove, if I know the element I want to remove, I can do that. With pop, if I know the index to pop, I can tell it which index I want it to pop. The dog's back there making noise, sorry. I don't know if she's audible. She's so goofy. Sorry about that. So with pop, if you know the element that you want to pop off, maybe you don't know the element, but you know the index. You just want to remove whatever element is at that index, you can use pop. Okay. Great. We're down to, we're going to get through everything. Index. Index. Okay, so index takes an element and returns, where's that 99s list? There's this one. Returns the index of the first occurrence of that. So if I want to do the index of 4, that's at index 0. If I want to do the index of that 3, that's going to be at index 2. If I want to do the index at 99, now this is a little different, right? Is it going to give me that index or that index? And it gives me the first one, the lowest one, right? So that's the one. Somebody might be wondering, well, what if I wanted to give me that one? I don't know. Maybe you could do slice of, I'm genuinely making this up. I'm figuring this out right now. You could start at dot index. Oh, 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 +1. Then we need to reconstitute. Okay, so this line of code is getting complicated. But we could do that. Oh, plus the index of 99. 0, 1, 2, 3, 4. Okay, well, I made it really close. That's actually at index 5. So I think maybe the thing to do is to add 1. I think that's the thing. So I think that would be, I'm pretty sure that would be a working algorithm to get the next occurrence of the index. But it's not a great solution. That's a lot. There's a bit going on there, eh? So in general, I don't think of index as a tool for that as much. If you want to know the index of the first occurrence of something, that's what it's there for. Of course, I don't really need to do that. Yeah. Let's just do a few of these. we'll do 4, 399, and 2. Okay, there we go. Okay, enumerate. Enumerate, if you have a list, you want to iterate through it. So if I want to iterate through elements, for element in list, print element. Oops, I'll say okay, so that'll iterate through elements. If I want to iterate through indices, oh, range len. Oh gosh, sorry. Range len. Iterate through indices. Like, wait, what? Okay. Oh, why don't I do this? That's better. So iterate through elements, iterate through indices. What if I want to iterate through indices and elements? Well, one thing, when push comes to shove, the simple range len loop just does it all. However, it can be clunky. If I really wanted to recover the elements from this, I could do list sub idx, but that's a little bit of a clunky way to say elements. I'd like to just be able to say lm like this. So this is where enumerate comes in. And if you wanted just an easy way to iterate through indices and elements at the same time, or just indices at all, you can use enumerate if you don't want to do range len. So enumerate list. So notice I have used enumerate in contexts that are not as the iterable for a for loop, but I don't know, 99% of the time that I use enumerate, I use it as the iterable for a for loop. I'm using it to alter what I'm iterating through in the for loop. Notice how it changes the for loop a little bit. So it allows me to identify two things instead of one. So, and it goes in this order, index and then lm. The names aren't important. I could call this fancy pants and Dave. Fancy pants and Dave, right? Like the names aren't important, but by convention, unless there's some other obvious good name to call them or something, you'll see index and lm or le, something like that. And I kind of will use lm or le either way. So for IDX, for index and le, in enumerate, list, print, index, and element. So that gives me both. So enumerate, I know we're covering a lot of things today. I don't want to necessarily prioritize, it's all important or whatever. If I were to give you two takeaways at this point, things that you really, really gotta remember and are gonna want to know how to use: count, which is nice and simple, and enumerate, which I think is a little funky because it changes the for loops, and you're used to writing for loops in a certain way. But let me explain how it changes the loop here, because it's not that weird. It's not like Python just sees that function and it's just like, well, I guess I'll just like make an exception and then just change the way for loops work for this one function, for iterating through this one function. This is a mechanic that pops up in other places in Python. So let's call this a thing. So we haven't talked about tuples yet. I think I've mentioned them. I mentioned that tuples are like lists. Tuples are like lists. If I haven't mentioned that, tuples are like lists. They're like lists without the immutables, without the mutable stuff. They have a very different sounding name, and they use parentheses, and I think a lot of times the way people describe them make them sound like they're something special or fancy. They're just, think about a tuple as an immutable list. That's really all it is. It plays by all the same rules, except you can't append to it. So it has immutable characteristics like a string, but it holds an arbitrary group of elements like a list. So a lot of things return tuples, including enumerate. So enumerate, if I were to just print this off, let me do this. Let me do this. Let's just take this. If I were to just print this enumerate off, we're going to get an enumerate object, but like the list reverse iterator object, and like a lot of things, like range, you can cast it as a list. If you're using something that's kind of vaguely list related and you try to see what it is, and it's like a such and such object at a location like this, just try to cast it as a list, see if it makes more sense that way. So notice, if I turn this into a list, it gives me a list of tuples, a list of two wide tuples or two long tuples, a list of tuples with two elements in each tuple, where each element is the index from the list being enumerated and followed by the element from the list. So when I iterate through this enumerate, it's just like iterating through a list of tuples. It's just exactly like iterating through this list. So if I say for I, or for thing in, let's call this enum list, this is going to behave exactly like enumerating. Ugh, what am I doing? Print thing. Well, it's going to behave, you should still do it this way. You should still do the enumerate in place here. This is weird. This is a weird way to do this. You could do it this way, but you don't actually want to make it a list and all that, right? But you'll want to put the enumeration here. But what I'm trying to get at is, like, in terms of iterating through this, it's going to give you exactly the same thing. So you'll see this chunk and this chunk are exactly the same. So just like in this enumerate for loop where I can do idx le, and I can say idx le, I can do exactly the same thing if I'm iterating through any list of tuples. I can pull it apart. I can unpack each tuple. So if you remember, I don't know, I think maybe we covered this in the first or second class, and I always cover it pretty briefly because I don't want people to spend a ton of time on it because it's not relevant until now. So, you know, we've gone, what, 2 weeks since then, so um, it's not really like really understanding unpacking something doesn't make a whole lot of sense until you're getting into enumerate, and then you're unpacking each tuple in the loop right there. Cool. Okay. So I know that's a lot to go over. We're going to talk a little bit more about unpacking in a second here too. Let's talk about zip though. Here's another function that does something similar with the loop. So if you ever have the question, but how can I iterate through 2 lists at the same time? Well, have I got a function for you zip. So it's kind of like an even more super powerful enumerate. We could even emulate the behavior of zip, of enumerate, by doing like range len, and this would essentially give us indices. We could do the same list or whatever, indices of one and elements of the other, just like that. Oh, sweet. Sorry, this dog here is whining. So this will allow me to iterate through 2 lists at the same time. In fact, it'll allow me to iterate through as many lists as I want, list 3. But let's say they don't all have the same number of elements for whatever reason. It's only going to iterate through as many elements as the shortest one has, ABC. Come here, come here. Okay, sweetie. Sorry, the dog is whining at me. Okay, we only got a little bit more class. Okay, Pokey. Okay, sorry. So for ABC in zip list 1, list 2, list 3, so this is only going to give me 3 iterations through because list 3 is the shortest list and it only has 3 elements in it, right? So I can do whatever I want with these ABC numbers in the loop there. I just realized, I'm going to go back to enumerate for a second. Let's go back to enumerate for 1 second here. Enumerate takes an optional second argument, which is where we want this index to start. Now it's kind of funny. So if I don't pass anything, it's going to start at 0. Now that, if it starts at 0, that is an index. If I start it somewhere else, it's kind of weird to call it an index because it no longer models indices. Certain, you'll see certain, mathematical formulas with a sigma where you have like a k or an I at the bottom and it says I equals 1 or k equals 1. And this is how you can model that, one way to model that, right? So you could call this K or whatever, where you want to start that counting at 1 instead of 0. But you could start this count anywhere you wanted, right? So I could start it at 500, and it's going to go 500 through 506. So it's kind of weird. The order it takes its arguments in is the list to enumerate, come here, and the number on which to start the enumeration, the index. But the order it gives things back is index first, or the enumerated number, then the element, always in that order in either case. Okay, cool. Parallel lists, this topic is the zip topic. This is an example of parallel lists, right? So when you have lists that you want to iterate through in parallel, right? So imagine if I had names equals James, Joanne, Jesse, and let's do ages. Let's say ages is, let's say 37, 31, and 89. Oh, ages. There we go. And let's say for name, comma, age, in zip names, ages. And then I can print the person's name and their age. So these lists are what we would say are parallel lists because their elements correspond across their indices, right? So an element in index I, corresponds to the other element at index I in the other list, right? So index 2 corresponds with each other, index 1 corresponds with each other, etc. So in order to iterate them together, through them together, we use zip. So anytime we're using zip, we're doing a parallel lists problem. Anytime we have a parallel lists problem, we're probably going to use zip. Unpacking, whew, kind of close. Unpacking, you can unpack a list. I showed a little bit of that. I'm going to get a little bit more granular, right? So this is an unpack right here. When we have this, so we've got this list of tuples, which is a fake enumeration kind of, because it's actually a literal list of tuples. When we have this list of tuples, we can unpack it in the for loop. That's an example of an unpack. Same exact thing happening here in the enumerate. We're unpacking each tuple that enumerate returns. Same thing in zip. We're unpacking the zip object that zip returns a tuple every time. If it returns a tuple with 2 elements in it if I give it 2 lists. Returns a tuple with 9 elements in it if I give it 9 lists. I could totally iterate through 9 parallel lists with zip if I really wanted to. So you can unpack in just a variable if I say a, comma, b, and notice that's the same kind of name, comma, age, right? I could do name, comma, age equals Billy and 57. Okay. Now print name, comma, age. It's going to be Billy and 57. So notice I didn't put brackets around this. I didn't put square brackets. I didn't put parentheses around this. You can actually just do this, and Python will understand this as a tuple. It'll just see that as a tuple. It is typical that when you're unpacking anything that it's a tuple, because if I try to unpack 2 elements into 3 items, come here. I get an error. If I try to unpack something else, I don't know, like this, if I try to put 3 things in 2 names, I get an error. So at the time that I'm writing this code, I need to be certain that there are as many elements to unpack as there are targets to unpack them into. And since lists are mutable, they can change size. So you don't typically unpack lists. You'll typically unpack a tuple. Since a tuple is immutable, you can guarantee its size. So at the time you're writing the code, you have much more certainty that it's actually going to be the size that it needs to be unpacked. That's why zip and enumerate both return tuples as you iterate through them. So this behavior will work in a list format. Oh, come on. It's so annoying. In a list format like that. But you typically don't see that. You typically see unpacking in variables or unpacking in anything. You typically see that done to tuples. Cool. All right, we are only 1 minute and 30 seconds over time. Sorry about that. But we got through everything. We'll just do a quick recap of this stuff next time, and then we'll be good to go. Let me stop the recordings. I'm going to start uploading things. I think the dog wants to go out, and then we'll open up for questions. So if you just give me like a minute to let her out, and then we'll go from there.